The gate control theory is basically a theory that explains how your body attempts to decrease pain perception. It can be split into two different parts. There's the ascending mechanism and the descending mechanism. The ascending mechanism part of the gate control theory is based on increasing a non-nociceptive stimulus from the periphery into the spinal cord in order to reduce pain. Essentially, this states that if you stimulate an A beta fiber, it will decrease the input of nociceptive stimulus from continuing to the second order neuron. This occurs because A beta fibers, which are large diameter afferents, try to close the gate that allows A delta and C fibers to continue to the second order neuron. On the other hand, the A delta and C fibers are trying to solicit the exact opposite effect. So basically, in the ascending mechanism, it basically comes down to whichever tract has the most activity will win and continue to the second order neuron, thus successfully closing the gate for the opposite receptors. So basically, if A beta fibers are being stimulated more than A delta or C fibers, then A beta fibers will continue to the second order neuron, and A delta and C fibers won't, and vice versa. The descending mechanism of the gate control theory was created because researchers kind of realized that the ascending mechanism did not explain the entire picture, because the brain itself has strategies of dealing with pain, but in order for the brain to actually deal with pain, that means the stimulus has to actually reach the brain. Therefore, the ascending mechanism couldn't be the only part of the picture. The descending mechanism is made up of basically two parts. You have the endogenous opiate system and the central biasing system. The endogenous opiate system basically states that when there is a prolonged, intense, painful stimulus, the brain, more specifically the hypothalamus, will stimulate the release of beta endorphins from the pituitary gland. Beta endorphins then enter the bloodstream and effectively decrease pain reception. Likewise, the central biasing system states that when a nociceptor reaches the brain, the periaqueductal gray region located in the cerebral cortex activates the Raphe nuclei, and the Raphe nuclei reduces pain by releasing serotonin, which then inhibits the second order neuron directly and indirectly stimulates the spinal enkephalin interneuron, which closes the gate for small diameter afferents. Thus, the painful stimulus isn't able to continue to travel up the spinal cord to the brain.